Hi, everyone. We'll wait a couple more minutes for folks to get started. Just maybe refresh a little bit. Boppy is out of town today, so he won't be joining us. We'll see if maybe the Yorkshire folks join or not. Oh, there we go. But I guess Kevin, did you have anything that you wanted to sort of start digging into today on
I
the
did.
MI side? Or okay, great.
I did, if that's okay.
Yeah, no, absolutely.
I don't know what we need for a quorum, but do we need someone
Yeah,
from OCP, or are you does someone host this meeting? Like, they have to be here for it to start, or
no.
all
I
of us
think
can join
this one
without?
starts. I used to have the access somewhere, but yeah, no, I mean all the sharing and everything is enabled, so I think no, there's no barriers.
Cool.
Hey guys, hey everyone.
Hey, Mod, how are you?
Good, how are you doing?
Good. All right, yeah, Kevin, we're at 9:03, so if you want, feel free to go for it.
Sure. I think before you joined the mod, the question was, is there anything that Yorkshire wanted to present today? But I do have some material, so I'm happy to go first if that's okay.
No, I think we had a discussion about what compatibility and modes and stuff means, so nothing basically around us. But well, basically just trying to clarify those terms,
Right. Yeah,
which I
without
don't
Poppy
know
here.
where
Yeah.
we left stuff. Yeah.
Yeah, good point. Good questions. Okay.
Yeah, I think the share button should work. There we go. Great.
All right. So unfortunately, Candu's not here either. So we had a couple weeks back, we went at the ODSA Friday meeting, that
Right.
high level project meeting. And I have a laser pointer. Here we go. So this was the standardization scope that I presented, and talking last Wednesday, it sounded like the best, the proper approach was just to sort of proceed through these in order. So it was really Can-Do that had emphasized the need to have some use cases, but that's what I plan to talk about today. Okay. And just Elad, what I did was I'm going to talk about both what I'm calling a die-to-die case and a die-to-memory case that sort of acts like in DFI like. And this is totally open, flexible, and happy to make edits on the fly to anything anybody wants to add to this. And then going forward, once we have a couple of use cases that are, let's say, aligned or agreed upon, I'm personally want to focus mostly on the DFI like case for 5 proposals, and then link that might go along with it, et cetera. And I'm assuming you, Elad, will lead memory chiplet discussions on the Axiolite case.
Yep.
Is that reasonable?
Yep, that sounds perfect.
Okay. So, but I'll talk today about use cases that hopefully bridge both. And actually, just before I forget, I know Boppy's out because he's at the supercomputing conference in this week. What do we normally do next week? I know there's meetings scheduled like on Thanksgiving, but I'm sure those are not gonna happen. But what about this meeting next Wednesday? Does that normally happen or no?
No, that's a great question. Oftentimes we'll do it audibly, so to speak, based on who's here in the room. Given that it's the day before, I suspect we'll probably cancel, but
Okay.
depending on how these discussions go and if we're right in the meat of it and folks want to meet, I'm happy to meet as well.
Okay, I'm probably not gonna be available next Wednesday.
No worries.
My mom's coming into town stuff, but
Yeah, no, I most likely I think we would have ended up canceling.
okay, anyway, that was an orthogonal right turn. Okay, so back to this. So I want to talk about number one on this list. So that's my focus. So here's what I have come up with so far. Two broad scenarios. So number one is I'm calling it a die-to-die logic to logic interface. Some memory chiplet for memory chiplets, but it is basically an extension of the NOC or running a protocol from one chiplet to another, which is like a lot of other chip-to-chip interconnects. So how is it different than just Bo today? And one of the keys is the memory controls on the chiplet, and the memory chiplet contains memory PHYs. So it is a chiplet that has, therefore, memory traffic, right? It is carrying over this logic interface, and therefore likely asymmetric traffic. I forgot to write that. But the idea is we might want to do something here that's different than just other logic to logic cases. And that's scenario one. And I contrast that with scenario two of a die to memory, where it's a logic to memory interface for memory chiplets, where it's an extension of the die-to-die interfaces we've been using, but more a die to memory connection for DFI. The memory controller stays on the ASIC, and the memory chiplet actually contains memory. Maybe it's a memory chip, maybe it's memory that's stacked on top of a logic-based die, but these were kind of what I thought I heard from the group as two broad cases. And in fact, what I'm going to do is get out of presentation mode here so I can make edits live. So feedback, thoughts, questions, people want to.
It's, at least to me, that seems to generally make sense. Maybe one clarification. In the second one, is there quote unquote an additional PHY inside of the memory chiplet? Or sort of the PHY on the logic die is implicitly or explicitly also talking kind of directly to the memory?
So I think the PHY in this second case, the PHY on the logic die is talking to a memory chiplet that contains memory. So there is memory on either memory inside the memory chiplet or memory. It may talk to another. Let's say their DRAM slices may be stacked on top of the chiplet, but the PHY in that case that is on the memory chiplet is 3D.
Right. Yeah, and I'm sorry, I should have asked this in a more, well, hopefully more clear way. I guess basically what I was asking was, are you envisioning that the PHY on the logic chiplet is basically talking to the DQ pins of the memory, or DQCA, etc. pins of the memory directly, or there's an intermediary PHY on the memory
I think
chiplet?
the intermediary PHY is case one, and talking directly to a memory chip is case two.
Okay, got it. Great. Yeah, just makes sense.
And here's the two. I drew two pictures. These are two pictures that I used last week, but I modified them to call them case one and case two. And case two, to answer your question, is I imagine that ASIC is talking directly to some kind of chip that is memory. Maybe the memory is embedded in the chip, or maybe the memory is stacked on top of it. I don't know. But the point is, the memory controllers in the ASIC, and these are basically address, command, and DQ pins, or is in case one. And I didn't do a lot of work. This is directly reused. So these benefits and stuff were not really relevant to our discussion, but the pictures are. Whereas case one, which is die to die, logic to logic, is taking a traditional case where you have memory PHYs on your ASIC and you take them off the ASIC in a way that the memory PHY is now on a chiplet, and this is only talking logic to each other. And maybe it's a modified logic to be more memory centric, but it's not very different than other logic to logic connections.
Yep. Great. Makes sense.
So the pictures were intended to try to, and these are reused from the previous discussions. You know, I guess I could say traffic may be a something like that, or okay, so these are the two we had talked about. So I tried, this is the sort of summary of the two use cases, and what I tried to come up with is kind of example targets. So this is what I based it on. This is the kind of thing where people, I don't even know, Elot, how we post material, but I can send this to you and Boppy, and others need to think about this and see if these make sense or they don't make sense. And I
Right.
know.
Yeah, no, what we've done in the past is we usually, you know, we'll make a PDF or something, and there's a spot in the GitHub that you know that we put presentations in. But we also just
that's
email
right,
things
that's right.
around.
So I don't know anything about that. But
Yeah, no worries, that's
we
fine. You
talked
can
about that
send it
last
to
week.
Boppy and me, and we'll figure that out.
Yeah, Boppy said he was gonna put specs there and all this stuff we talked about last week, the mechanics of how we proceed. Anyways, okay, here's the two use cases. So for the one you were asking about where it's directly connecting to DQ pins, the use case I'm thinking about is an HBM4 DRAM. You need to have, that means the read or write bandwidth is 2 terabytes per second, and it's or it is either one direction or the other. That means you're implying the far more efficient to use dynamic bidirectional PHY. There's some overhead on top of that, so typically what we target is around 2.5 terabytes per second of total bandwidth, but some pins are unidirectional and some pins are dynamic bidirectional, and you have to fit that in a certain beachfront, in this case. Significant.
Kevin, I have a question, sir.
Yes.
Yeah, in case one, I think it's is it not expensive to have a D2D and memory controller? Are there two chips, the green one and the yellow one? Are you saying it as the two chips?
Yes.
Is it right? So is it not expensive? Why do we need to go that route? Is there any advantage?
Happy to talk about that. So what you're saying, why would you move the PHY and memory controller to a separate chiplet?
That's right.
Yeah. So
that's exactly.
So companies are already doing this, and the reason is three things. These PHYs are really big, and the DDR PHYs, excuse me, the DDR, I should say, PHYs are really big. They take a lot of area on ASIC, which is very expensive. It takes away from your room allocated for GPUs and CPUs and stuff like that. Die-to-die PHYs are much smaller. And if you can prove out your DDR PHY, you could reuse the memory chiplet and design it on a N+1 or N+2 process that's much cheaper and dedicate more area to processing on your processor. So companies, you know, if you look at AMD, Intel, they're actually all already doing this. It's just they're all proprietary things that they're using. There's no you know, and so we could use both for that, or UCIe, I suppose. There's a lot of example positives of moving the memory interface off of the processor. So people are, I guess, already doing this. And what talked about in a meeting a couple weeks back is you could use Bow as is, but most likely there's reasons you would want to make modifications to the interface. I think
Mhm.
Elon corrected me a week ago that it's already allowed to have a different. Today in UCIe, it's required that the transmitters and receivers are the same number, right? So your bandwidth, read and write is identical. That's not very efficient for a memory chiplet because bandwidths are almost always very asymmetric. Bow, I thought it was also required in Bow, but it's not. It's allowed to be asymmetric, but there's complexities for the link layer and other things that the general cases don't sort of envision. So this is more of a use case of Bow where you would pre-configure it so that you had half the amount of write bandwidth versus read in a Bow PHY and modify maybe the link layer to support that and come up with let's say a configuration example of Bow to support these sort of separate memory chiplets for the people that want to do them. You know, people don't have to separate the memory chiplets and people don't have to, they can still use completely symmetric bandwidth and you just power down all the transmitters that aren't being used when they're not being used and you waste area, but you don't, you could, it's a non-optimal solution, but it's obviously already being done. But this is a way we could sort of come up with a roadmap for people that want to have a more optimized use of their interface for something like a DDR chiplet.
Got it. So what you're saying is the asymmetry in terms of number of channels and also speed.
Right.
So
Asymmetry of to make it more memory friendly, you'd be looking at the asymmetry of the traffic and the speed in each direction. Yeah.
okay. So upward link, let's say if it is 16 gig, downward could be read could be 16, write could be 8. That's what you're looking for. Something like that.
That's a specific example. I didn't get into that level of detail here, but that could be. Now it is let's see. An additional point that needs to be considered is there are unidirectional signals in any memory, namely command and access control and stuff like that. It may be that you end up with a symmetric number of pins, but you dedicate, let's say I'm just making this up. Let's say you dedicated 8 of the directions in one direction for command and control and 8 for write bandwidth and then 16 for read bandwidth. You'd end up with 16 in each direction, but you'd end up with fixed half the bandwidth for writes versus reads. That's a possible configuration that could be done. I don't know if it makes sense or not because I haven't done the math. The math I threw out was, I know that a DDR5 DIMM is supposed to be 64 gigabytes per second at the top end, the 8400 or 8 gigabits per second. So I said, well, if you're going to support 2 DIMMs like this, that would be 128. So that's a use case. This is like, we have to come up with targets and these may be good ones or bad ones. And I know you already have something in mind, Elad, so I'm fully expecting you to edit this and change it to something that you think makes more sense if this is off target, but this was like a starting.
Yeah, no, sounds good. This I think is all a good starting point for sure.
So that was
pretty good, sir.
Yeah, I thought it was reasonable, but that the purpose of this group is to provide feedback and change it. But for 1, that was some targets, and for 2, this is some targets. The difference for 2 is we would target a bandwidth that you could have in either read or write, which means where these could be still fixed unidirectional links, as the Bow is done today, or bidirectional links that get configured at initialization, but still in operation, they're fixed unidirectional links. These would require adding an optional mode to Bow that supports a dynamic bidirectional, which is how DQs operate today. So this is all for the DQ pins would have to be dynamic bidirectional, and the control pins would be fixed unidirectional of some kind. This is so these are my sort of straw man target use cases. What do we think? Any feedback?
The second one, I think, is, are we not competing with the DDR? If you want to make it bidirectional, you need to come out with all the baggage. Is that right? Yeah.
So the idea here is, it competing with, it is an alternate memory type interface that allows you to connect direct to memory if such memories exist. Ultimately, if they could be custom memories, which there are a number of companies looking at right now, or they could be a JEDEC defined memory. Defining an interface doesn't compete directly with a memory. It enables a memory to be defined, in my opinion.
Yeah, I think that's a good point. I think it's probably misquoted here. So whatever the thing you need to do to satisfy the DRAM interface, that whole baggage is going to come out to your D2D interface. Is that right?
Yes, you would need to do it. You know, it's a little bit tricky to answer that question. The reason is that there are three types of what you call baggage, right? So there's the DQ, which we would have to do something to support all the data. There is some control like command and address, and also error reporting and stuff that comes back. And ECC is a big part of memory. It's why memories traditionally are not binary. I didn't mention that, but I should. There typically means instead of a by 16, you'd want to by 18. All memories are defined that way. Correct me if I'm wrong, Elad, but I don't think Bo supports that currently. We have by 16 and by 8, but I haven't. Can we do any arbitrary amount, or is it?
Yeah, no, it's a good question. We haven't explicitly defined it. In principle, we can. Well, okay, I should take another step back. There is already the optionality for quote unquote FEC and AUX.
That's true. That's true.
We don't explicitly say that you can't use them in the way that you're describing. So, so I don't, I think somebody could fairly easily decide to do that.
All right, so I added a note here while I was talking about it. So
Yep.
I only have one more slide, and then I'm happy to talk about anything. When I meant by scope here, and this may be the wrong word, but what I see going forward is we needed to define a couple of use cases, and we had been heading toward two directions. And what I think is going to then happen going forward is, for example, Elad has mentioned, it may be, since asymmetric is already allowed, it may be there are no proposed changes to the BO-PHY spec, but under the number 2 use case, there definitely would be, in dynamic BiDi is just an obvious example. And then in the link layer, what Elad had said, what I heard you say, could be wrong, is that currently the link layer is specified for a certain. It kind of ties tightly to the BO by 16, and so if we have asymmetric traffic, there might need to be a link layer. And I made this up, but I mean, if it's AXI that's being extended versus Chai versus something else, would you envision that there's link layer changes that are dedicated for each protocol, or is it is that
yeah, so yes and no. So basically the way the link layer is spec'd right now is there's so-called interface profiles and bus variants that you can use to define both which protocols and sort of the optionalities within them. So yes, we would definitely be defining interface profiles. We would also very likely be defining bus variants. And by that I mean, okay, hey, so like, and yeah, so that essentially that would be saying, okay, when you're using Axie, use the following version of Axie, right? Or versions, as the case may be.
Ah, boy,
Um,
that's a whole, everyone talking about Axie like it's a one thing, but it's not, so.
Exactly. So yeah, so all of that, definitely will be defined. I think in principle the link layer, yeah, anyways, whether there might be some change for the asymmetry part of it. I need to go back and read the document, again to sort of see if there was anything that like was implicitly or explicitly saying otherwise. I think in principle it can be done in an asymmetric way, but there may be some there may be some tweaks for that.
And it doesn't really, the thought of writing this was just to lay out some possible changes that we see might
Yep.
come from these. It's not constricting us that these are the only ones allowed or anything. It was
Oh
just
yeah, no, for sure.
for our
Yep.
conversation here. And then this configuration doc, again, I asked if there's an example. It sounds like this is something that Bobby thought of on the fly of doing, but the idea is you would do something that would tie together how you would configure the FI and how you would use interface profiles. So
Yeah, that's correct. And it's a thing we've talked about for a while, but I think this is perhaps the one that's
that drives it.
gonna kick us enough to actually do it.
Okay,
So I have a quick comment here.
sure.
So for the option 2, I think one side connects directly to the memory, but the other side is going to connect to the memory controller.
Right.
And I think depending upon the type of memory, we have different memory controllers available, and most likely it's going to come from the same vendor who's also going to provide us the memory.
Right.
So I think we are already having a challenge in the link layer to support n number of interface profiles. With the option 2, it seems like we now also have to support new interface profiles for each of those memory controllers, because the controllers would be talking a different protocol based on whether they are talking to a DRAM, whether they're talking to HBM, whether they're talking to a DDR. So each controller would have its own protocol. And I'm not sure if different vendors follow different protocols for the same type of memory, but I hope not. But it seems like we are opening up ourselves to support a large number of interface profiles if we go down option 2. That's what I feel. I don't know if others feel the same. So I mean, option 1 seems like a more common use case, but I may be wrong. I don't know. I mean, what does your market research tell you?
So I would answer that a little bit differently. So I think for the cases that you mentioned, say a DDR chiplet or LPDDR chiplet for memories that already exist, you can't connect directly to them with option 2. So they're going to be over here in option 1, like you said. What's going to be over in option 2 are new memories that are defined as a direct connect chiplet interface with much lower power. So there could be a new low power wide IO memory that uses something over here, but you don't have to redefine all of these for the existing memories, because the existing memories can't be connected with a BOW interface. That they can only be connected through an intermediate chiplet, and this is the intermediate chiplet case on column 1. So I agree with you that there could be different interface profiles for different memory types that get defined, but not backward looking. These are more going to be forward looking to new memories that get defined, and they're not going to be generic GDDR5 or DDR5, because DDR5 already has an interface. It's going to be something that's defined with a die-to-die chiplet interface.
Oh, I see. Okay. And okay. I haven't
It's
heard
new
of such memories, but I mean, do you know if there are some memories like this being developed?
So being developed, what I would say is there's memories being proposed. There's memories being proposed to try to use die-to-die interfaces for wide interfaces, and instead of the very high power and interfaces that are currently used. So there are things being proposed, but what they would like to do is use an industry standard interface versus, and they don't have one out there because UCIe doesn't work and BO as currently defined doesn't work. So that was the base background for why we would propose to make changes to the BO spec to enable such memories to then be defined in JEDEC and other places. JEDEC moves so slowly that I'm not, it's going to be a while before anything's actually in design.
Got it. Thanks.
So I don't know.
I think that this all makes sense to me, as you said, right? We should, I can certainly help with kind of gathering some more example cases of, bandwidth configurations and things like that for the,
right.
For case one. But yeah, in general, I think this makes a lot of sense.
Yeah. So if there's we had good discussion. We already added stuff in this meeting. If there's other use cases than these two, if we want to add a third, I don't know. I think these were the two broad ones that you and I have been talking about, Eli, but this is just the purpose of today was to kick off this discussion. So I really appreciate all the discussion and feedback, and I'll send these to you guys so they can get uploaded, and we'll get more people who weren't able to join us today, ask more questions, and hopefully back to the, if we can close on our use cases, then we can start moving forward on proposed, how we would address them as the next steps in this group going forward. That's my thought.
Sounds great to me. Thank you, Kevin. So, and I'm sorry, Maud, you mentioned in the beginning, did you say you think you do have some more things for discussion for today, or not currently?
Well, I mean, basically, it's not me. As a group, we wanted to discuss what does compatibility mean,
right?
And I guess it was just a conversation we were doing last week, and sort of wanted to continue to this week. But I don't know if it makes sense because Bob is not here and Cash is not here.
I
but
think
it was more of a quote unquote conversation we were
Right.
having, and I don't remember where we left it off. That's I guess
I-
a problem.
he took some, he wrote some things down that he was gonna,
Yeah. Okay.
he
Yeah.
said some things and we were like, hey, that sounds good, but I don't remember if he sent out minutes or any notes after the meeting. I do remember, in the example that you were talking about where you had went from 16 to 8-bit wide, but it still had, for the one scenario where it had, clocks in both directions and all that, he was going down the direction of that could be completely compatible and that it could interoperate. Whereas the change I proposed with this by dynamic bidirectionality will kind of be derived from a BO5, but it's not necessarily going to be compatible. That was the two examples I thought he was using in the meeting, but we never did, like you said, close completely and write it down. And everybody said, yeah, I agree with those words or whatever. So I think it's still hanging.
Yeah. I guess maybe when he's back next week, when he has the notes, that we can continue.
That's good.
Okay, yeah, sounds good to me.
Yeah.
Unless Mark would be the only other person that I think maybe would have a immediate comment for today. But if Mark, if you prefer to postpone it, I guess it probably won't be next week, just given Thanksgiving, but 2 weeks from now. But anyways, yeah, Mark, if you have anything you wanted to chime in on, feel free.
No, I think that sounds good to me.
Okay, great. in that case, I think we can give folks 24 minutes of their lives back. Thank you very much, everyone.
Thank you.
Thank you.
Thanks.
Have a
Bye-bye.
good one.
Talk
Bye.
to you soon. Bye-bye.
Thank you. Yes.